Let's talk about oil pressure. How much of it do you need and why? This is a topic I never see covered anywhere, but it's important because it applies to all of us. And we did a couple of videos last week that contribute to this. The first was that we did that video on classic cars and fuel economy. And also we did that one looking back at the old direct connection racing manuals. And one of them was this, the fuel economy tune-up tips. So in here, one of the things they talk about in terms of saving gas is reducing the engine's oil pressure. It frees up parasitic losses inside the engine. It can take a substantial amount of power to turn that oil pump. So the less of it it's subjected to, the better off you are all the way around. But now, how much oil pressure do you actually need? And what is going on that you need that much oil pressure? So let's look at two extremes of the spectrum, okay? This Harley Davidson has an oil pump. Now, the bottom end of the motor is all roller bearing, but the top end has rockers with bushings. So the oil pump on this engine only exists to pump oil up to the rockers, and then from here it drips down onto the crankshaft. Now you can't pressure oil roller bearings because the roller won't roll anymore. It'll actually pile the oil up and it'll skid on the oil. And so, or it'll skid on the journal, I should say. And that'll overheat it and destroy it. So for this type of engine, 2 psi, 3 psi, that's all you need. On the opposite end of the spectrum is this. So this is an oil pump from an old fuel dragster. The ones that they use today are pretty much identical. So inside of here are two high volume, high pressure 426 Hemi oil pump assemblies, the gear and rotors, stacked together. Let me get this off. Now you can see in here. And they're actually stacked together. And the purpose of this thing is to force 70 weight oil at approximately 125 psi at idle through the engine. And why does it need so much oil pressure? Well, two reasons. First, you've got the jackhammer combustion pulses, but you've also got huge internal oil clearances. So the hotter the engine, the looser it has to be to keep itself from binding up and getting that hot metal-to-metal contact. Fuel motors, race motors, high horsepower motors are built with very large internal clearances, large main bearing, rod bearing, oil clearances, lots of end play on the rods. So basically, the engines hemorrhage oil internally. This keeps it flowing. This keeps the heat away from the assembly. Because remember, one of the purposes of oil as it flows through an engine is to remove the heat from the reciprocating assembly. Heat starts at the piston, works its way down the rod, and before it gets to the rod journal, the oil, as it flows through, carries some of that heat away. Oil cooling. It's one of the common features of all pressurized oil systems. The oil actually helps to cool the engine. But those are the extremes. No oil pressure, huge oil pressure. And we're right there in the middle. So for the context of what we're talking about here, we're dealing with the typical type of engine that a viewer on this channel is going to build. 300 to 600 horsepower, 6,000 RPM, based on production parts, close to production parts, basically production crankshafts, connecting rods, internal clearances, all basically, production in that range. So how much oil pressure do you actually need? How much of it is a throwaway? Well, the old wisdom is, and this is according to Bill Jenkins, this is according to Smokey Yunick, the ballpark figure was 7 psi for every 1,000 RPM. You can round that up. Basically, if you're running 6,000 RPM, you want to see approximately 50 psi, and that's going to keep everything happy inside the engine. So why? What exactly is this oil pressure doing? Why is it RPM related? And you notice that oil pressure is always more RPM related than it is horsepower related. Nobody ever says, well, I'm adding 100 horsepower to my motor, how much oil pressure do I have to add? It's an RPM factor. Now, combustion pulses do figure into it, but the combustion pulses are really just aggravating the main situation inside the engine, which is centrifugal loading. So as the motor is running, the big end of the rod cycling around like this, centrifugal force is trying to throw it out to the side. So at 1,000 RPM, you've got X amount of pressure on the rod to the outside, going to the outside of the journal, and you need X amount of pressure of oil to maintain that wedge between the bearing and the journal. The ballpark figure is 7 psi for every 1,000 RPM. That'll keep the wedge going on. Less than that, and what'll happen is the oil wedge will get squished out of the way. When the oil wedge gets squished, then you've got contact between the bearing shell and the journal, and it only has to last for just a split second. The rod bearing will try to weld itself to the journal. It'll break the little tangs that holds it in place and spins. Generally what happens when you've spun a bearing. So that 7 psi is a minimum. At idle, you want maybe a little bit more than that. So let's just say you're dealing with 1,000 RPM idle. You want more than 7 psi at idle. 10 to 15 is enough to do the job. If you go all the way down to 7 at idle, what happens is if you're dealing with a hydraulic lifter engine, the lifters won't maintain their pump at that level. Which is like, for instance, Chrysler's, actually most production cars, the idiot lights are set to go off at 7 psi at idle, because less than that, and then the lifters won't stay pumped up. So idle, hot idle, you want to see maybe 10, 15 psi. Cold oil pressure is a completely different thing. So you start the motor, it's cold, you've got 40 psi at idle, that's fine. The oil is thick, the internal parts are still cold, they haven't expanded yet, and so higher oil pressure is always to be expected when the engine is cold. But once everything is fully up to operating temperature, then you want to see that idle, you want to see 10 or 15 psi. That's fine, that's all you need. I know a lot of guys want to see 30 psi at idle, but you're not doing anything except throwing horsepower away, turning that pump. It's not doing you any favors. So as long as you can maintain that minimum of 7 psi for every 1,000 RPM, that's what you should shoot for. Right away, people build a high performance engine, they throw a high volume, high pressure pump in there. Don't do it. Unless you've got larger than stock clearances, bearing clearances and rod side clearances, you're not doing yourself any favors. Actually, you're backing the oil up. You're increasing the pressure in the oil. You're actually aggravating where the oil is supposed to be taking temperature away. You're adding temperature to the oil by making it stack up before it can exit. So, and you're throwing horsepower away. It takes power to turn these things. I mean, I've seen people, it's fairly common, a high pressure, high volume pump, and see, like for instance, this is from a small block Chrysler. It's fairly common to see one of these engines with the end of it twisted like this, or the gear will slip on the shaft. When you go to those high pressure, high volume pumps, you're supposed to drill the shaft over here. You're supposed to drill through the gear on the shaft and put a pin in there to keep the thing from rotating. So you don't need to go there if you're only dealing with, let's say, 6,000 RPM, 500 horsepower, stock internal clearances. You don't need to go anywhere near there. A stock oil pump, providing everything inside the engine is healthy, a stock oil pump is all you need. It's going to do the job. Now, if you've got a good pump in the car, in the engine, you've got good clearances, your pressure is high and you want to lower it, you go with a thinner oil, right? I mean, you got to experiment. You got to see what your engine is going to be happy with. If you're running like a 40 weight or a 30 weight, try a 20. Drop it all the way down to 10. Whatever you have to do to get that pressure down. And like I said, you will see the difference. It's worth several horsepower. It's worth, I mean, you can feel the difference just in throttle response. Especially on a lower horsepower engine, you will feel it. So that's it. The simple basics of oil pressure. How much of it you need, and a minimum, and why. And I hope you got something out of that. I'll see you tomorrow.